When we are multiplying radicals and when we're dividing radicals or simplifying them in general, I tend to think of it as like when you're cleaning out a closet. You have to pull everything out and reorganize in order for things to get clean. So a lot of times it looks messy before it gets to look simpler. So with radicals, when you're multiplying them, as long as the index or the root number is the same, you can multiply the radicands or the things on the insides of the radical. So what that means is, in example number 1, we can multiply 3 times 5 inside the radical because they both have an index of 2. So we can make this one radical of 3 times 5, which is just the square root of 15. Now, the square root of 15 can't be simplified because all it breaks down to is 3 and 5, or 15 and 1, and none of those are perfect squares, so we can't simplify this anymore. On number 2, on the other hand, we can try to simplify this. So we're going to use the same property. When we are multiplying radicals, you can go ahead and just multiply them straight across. So 15 times 6 would be 90. And then you want to simplify that if you can. So 90 is 9 times 10, where 9 is a perfect square. And we can simplify that to be 3 square root of 10. So that would be our final answer for this one. However, you could start simplifying from the very beginning. We could break this down to the square root of 3 times the square root of 2. And we could break down 15 to the square root of 3 times the square root of 5. Now, no, none of these are perfect squares, but remember, since we're multiplying them, we can multiply all 4 of these together in any order that we want. So that means I can multiply the 2 square roots of 3's together, and I could multiply the 2 and the 5 together. So that would give me the square root of 9, which is 3, and the square root of 10, which is what I just got. So you can do this in any order that you want. You can multiply first and then simplify, but typically if your number is any bigger than like 120, any numbers that get bigger than that, they tend to get a little bit messy, a little bit hard to simplify. So I like to simplify in the beginning, but it's up to you. All right, let's try some more. The square root of 8 times the square root of 6. You could multiply them straight across and get the square root of whatever 8 times 6 is, and that's 48. And then you can simplify and see what's the biggest perfect square that goes into 48. That would be 16. So the square root of 16, and then 16 times 3 is what gives us 48. So that would be 4 square root of 3. Or we could simplify in the very beginning. So this would be square root of 4 times square root of 2. Square root of 3 times the square root of 2. And now we can multiply these together in any order we want. We already know that the square root of 4 is 2. And then we could take our 2 square roots of 2 and add them together, or multiply them together. So that would be the square root of 4. So when we simplify that a little bit further, that would be 2 times the square root of 3, which again is 4 square root of 3. So you see how messy things get before they get cleaned up, and that's just because we are breaking them down as much as we can and then putting them back together so that they are as simple as possible. All right, number 4. We can multiply these straight together, but if I'm looking for the square root of 350 and trying to simplify that, I'm going to have to do a lot of guessing and checking to find the perfect square that goes into 350. So instead of doing that, let's go ahead and break this down. So this would be square root of 5, square root of 2. And 35 can be broken down to 7 and 7 times 5. So square root of 5 times square root of 7. So we're just multiplying all 4 of these together. We can do that in any order that we want. So we can combine the two square roots of 5 that we have, and then we can combine the 2 and the 7. So that gives us the square root of 25 times the square root of 14. So that's 5 square root 14. Now we always want to check the square root of 14 can only be broken down to 7 and 2, and neither of those are perfect squares, so this is as simple as it can get for us. All right, and then 150 times 30. So if we were to multiply those straight across, 150 times 30, let's see, that would give us 4,500. Okay, that's a really big number. It's going to take us a while to figure out the greatest perfect square that goes into that. So let's start by breaking this down. So we know that this would be the square root of 15 times square root of 10. That's just two easy factors. It's a starting point. So here, let's think of some numbers that go into 30. We could pick 6 and 5, or we could pick 3 and 10 since I already have a square root of 10. All right, well now I can rearrange these in any order that I want and multiply them together. So I'm going to do the 10 times 10, and then the 15 times 3. So the square root of 10 times 10 would be the square root of 100, and then we have the square root of 45. Well, we're not quite done. We want to keep on going. So the square root of 100, we know that that's 10, and then the square root of 45, that can be broken down to 9 times 5. So the square root of 9 and the square root of 5, and the 10 in front. The square root of 9 is 3, so that's 10 times 3 square root of 5. So our final answer is 30 square root 5.